Topic of this video is the first reaction with alcohols. And you've seen the reverse reaction before, but in the sense that you've seen a hydration. You've seen alkenes, just for example, be hydrated to make alcohols. But now it's the reverse reaction. And how you can make the reaction go backward from what's above is you change the concentration of acid. So CONC means concentrated, H2SO4. That means there's very little water, and equilibrium, a topic from 104, would drive the reaction forward to produce more water. So what I mean by that is concentrated H2SO4 means that you have a low concentration or a low amount of water. So the reaction will shift to produce more water. So this is an alcohol dehydration because the alcohol is having water removed from it to make an alkene. But if you have an asymmetric alcohol, so what I mean by that is you've got one carbon to the left of the carbon that I'm highlighting in red. You've got one carbon to the left of it, two carbons to the right. So it's asymmetric in from that perspective. You've got two possible products. You've got the double bond forming to the left, or the double bond forming to the right. Meaning here, the double bond forming to the left or to the right, plus the water that's removed from the dehydration. And the rule, it's called Zaitsev's rule, is to describe which alkene is favored. Is the alkene with the fewest carbon-hydrogen bonds at the vinyl carbons, meaning the carbons that are in the carbon-carbon double bond, those carbon atoms, is favored. So if we draw the implied carbon-hydrogen bonds, the alkene on the left has 3 carbon-hydrogen bonds. The alkene on the right has 2. So that is the major product of the reaction. There are fewer carbon-hydrogen bonds. And language that's used, this is called a disubstituted alkene, because there are two carbon-hydrogen bonds. Okay. The other two possible positions that could have been carbon-hydrogen bonds are substituted. To make a little clarity. That has three carbon-hydrogen bonds, okay, and one has been substituted for an alkyl group. Therefore, this is monosubstituted. And it is because it has three carbon-hydrogen bonds. One last example. That alkene, we draw the only implied carbon-hydrogen bond that is tri-substituted. Only has one carbon-hydrogen bond. An alkene that would have no carbon-hydrogen bonds at the vinyl carbons, that is the carbons at the double bonds, would be tetra-substituted for 4. And that's how you predict what the product will be in an asymmetric alkene. Okay, whenever you have an asymmetric alcohol being dehydrated to form an alkene. So just some more practice. So we've got that alcohol treated with concentrated sulfuric acid. Step 1 is just draw the two possible products. The double bond can either go here or there. It has to go to the left or to the right of the carbonyl carbon. That is the carbon that's got the hydroxyl bonded to it. So we've got and then of course water. Then draw the implied carbon-hydrogen bonds. The alkene on the right has 2 carbon-hydrogen bonds. It's di-substituted. It has fewer carbon-hydrogen bonds around the vinyl carbons. Therefore, that is the major product. What's on the left would be the minor product. For major means you would get that in a greater amount. Minor means you would get it to a lesser degree. And that's how you draw the products for and predict what the major product will be for the dehydration of alcohols into alkenes.